In today's video, we're going to walk through one of the most powerful but overlooked tools that is built right into every single Android phone. And that is, of course, the bug report. I'm going to show you how you can generate a full bug report on an Android phone, how you can pull it from the phone onto your Linux system using ADB, and then more importantly, how you can analyze it using a tool called MVT, or Mobile Verification Toolkit. And we're going to check the bug report for indicators of compromise. We're talking about malicious activity, spyware, stalkerware, anything that would indicate that there is any type of compromise or malicious activity that has taken place on the device. Bug reports might look like simple diagnostic files, but they actually contain a detailed snapshot of the device. System logs, configuration states, running services, clues that can help you spot suspicious activity. If you're interested in mobile forensics, threat hunting, or just protecting your phone, then the tools that I'm about to show you today are a great starting point. Let's get started. So a bug report contains device logs, stack traces, as well as other diagnostic information that can be used to help you find and fix bugs in your app. That is the traditional use for a bug report. But bug reports contain so much information that they can actually be used for much more than just that purpose. So from a forensic standpoint, a bug report contains pretty much everything. And from the standpoint of, say, OSINT, where you're just trying to gather information, once again, bug reports are gold mines. The key is being able to effectively use the bug report, or even being able to visualize the data that you're pulling out of the bug report. So how do you take a bug report? Well, there are actually a couple different ways that you can do this. So as it states, to take a bug report, first and foremost, you must have developer options enabled on your device. So it walks you through how you would take a bug report using the actual phone, but you can also take a bug report from the command line using ADB. No surprise there, as ADB is incredibly powerful. And by default, the bug report is a zip file. It ends in .zip. This will contain multiple files, but the most important file is a file with the bug report -build ID date timestamp. That's the actual bug report that contains all the diagnostic output for system services like dump sys, error logs from dump state, and system message logs from logcat. The system messages include stack traces, when the device throws an error, and messages written from all the apps with the log class. Okay, so if you're interested in taking a bug report by actually initiating key presses on the phone, we will first cover that. So to show you that, I'm going to start up one of my favorite tools for interacting with Android, and that is, of course, screen copy. I'm going to do that with -- always on top. You're going to go into developer options, and at the very top underneath memory, you can see that there is a button for bug report. You click bug report and you're given two different options. You have an interactive report and you have a full report. When you want more information, you're going to opt for a full report, and you simply would check mark that box and then click report. But the preferred way to take a bug report is to do so from the command line. So we can shell into the device by running ADB shell. I'm now inside of the phone, and the commands that I execute are being executed on the phone. So if I run who am I, we get back that I am the shell. I run the date command, we're getting back the current date on the phone itself. Here is the directory structure, and there is actually a directory called bug reports. If I cd inside of bug reports and do an ls, This directory contains all of the previous bug reports that have been initiated on this phone. So this is where previous bug reports will be stored. If you wanted to extract one of these bug reports from the phone, then you would obviously just get the path to this directory, which is very simple. pwd tells you we're inside of bug reports, and then grab the name of the zip file. Use this one for example. I'm going to exit from the phone. I'm going to cd inside of a directory that I previously created. It's called Android, and I'm going to use the make directory command. I'm going to create another directory for what we are doing today, and I'm going to call that directory bug report. Now cd inside of bug report. Alright, so if I want to pull that bug report off of the phone, it's very simple. I'm just going to run adb pull and paste in the path followed by the name of that bug report. It ends in .zip. And hit enter. And now I have the bug report on my Linux machine. I'm going to remove that bug report because we are going to generate a new bug report. This is my preferred way of generating bug reports, not on the phone, but straight from my Linux terminal. So we're going to generate the bug report and simultaneously bring that bug report over to our machine, our Linux machine. Okay, so for us to take a bug report from the command line, it is incredibly simple, though there is a syntax that you need to abide by. You're obviously going to make sure that you have a connection with the device. So I can verify that by running adb devices. You see that we are attached. So to both generate a bug report and simultaneously save that bug report to the current directory on my Linux system, I'm going to run the command, the adb command, adb bug report. The mistake that a lot of people make is they then redirect that into something like bug report .zip. But in actuality, you're not supposed to include that redirector operator. So the syntax is adb bug report followed by the name that you are giving that bug report, which is going to be traditionally bugreport.zip, and hit enter. So in other words, when you run the adb command adb bug report, it automatically directs that output into that file that you name bugreport.zip. Okay, so the command has completed, and as you can see, technically it did pull a file from the phone. So it does tell you that one file was pulled. So in other words, that command did create a bug report. It created it on the phone, and then it immediately extracted it or pulled it from the phone. So now we have a file. It's called bugreport.zip. I can run ls-lh on that file, give us a human readable size. It's approximately 7 megabytes in size. Now from this point, you could obviously manually unzip this and inspect this. It is just a simple zip file, so we could, let me copy this first to a backup before I do anything. I'm going to copy the bug report to a backup file. Now we could just unzip this. You see every single file that makes up that zip file printed to the screen. And if I run ls, we now have everything in the terminal. So we have directories and files, and we could manually inspect the results. There's a bunch of stuff, inside of FS. Run the tree command on that. We have almost 100 files, and there's going to be quite a bit of information. But to manually go through all of these various files, obviously that's not going to be fun. That's going to be time consuming. It's not going to be efficient. So there is a much better way that we can utilize this bug report, and that is going to be by leveraging the power of the Mobile Verification Toolkit. Yes, I have been doing a lot of videos on this toolkit. It is absolutely incredible. It is incredible, it is powerful, and it is capable of doing so much, and it does it in a very straightforward and simplistic manner. So I have done previous videos on this. I've covered the installation as well as running some of the other commands, so I'm not going to cover any of those things in this video. Instead, we are going to go straight down to the command line. I'm going to clean this up a little bit, and I'm going to get rid of everything other than just that bug report. And I'm going to start up the Mobile Verification Toolkit, specifically the Android version of that, because there is an Android version as well as an iOS version. Here are our various commands. If you want to check the current version of MVT that you are using, you can do so by simply running the version command. This is version 2.6.1. The indicator updates are done automatically, so you see that the next automatic check will take place in 10 hours. But if you need to do this manually, so say for example if you're doing this for the first time, you do need to make sure that you download the IOCs, because the IOCs are a large part of this tool. Yeah, the tool is essentially, it's not useless, but a large amount of its power is derived from the fact that it has these IOCs to make comparisons to. So you're going to want to make sure that you first download the public sticks-to indicators, and you can do that by running MVT-Android followed by download-IOCs. You will see that they are printed to the screen in this wonderful colorization. Over here in green are the actual downloads. Okay, so now that that is completed, we're going to run the check bug report command. This is used to check an Android bug report. Now what we mean by that is that it is going to parse through the entire contents of that bug report, and it's gonna do its magic on that bug report. And part of that process is going to involve running a multitude of different modules on the output that is contained within that bug report, and it's going to be looking for indicators of compromise. Now we can actually pull up another smaller help menu for the actual check bug report command. So one of the things that we need to do is we need to specify a path to a folder where you want to store all of the results, and the results are going to be in JSON. So you have to specify an output path. Alright, so the directory that I'm going to use for the output directory is simply going to be my current directory. Now I could probably reference that with a dot, or I can provide the full path. I will provide the full path. So the command is going to be as follows: MVT-Android followed by check bug report followed by -O, and we're going to specify our output directory, which is going to be where I am currently at in my file system inside of bug report. And then finally, Finally, you have to provide the path to where the bug report is located, and that is also in my current directory, and the name of the file is bugreport.zip, and hit enter. And you can see it has begun the process of going through everything, and it's going through it very quickly, and it is already done. Very, very quick, very quick. So we can start examining the results. If we go back up to the top, there is a general structure to everything that you see on the screen. It is actually very similar to how you might see things logged in Python. So everything starts with a timestamp, and there are different levels to the logging. Then you have your actual full path name for whatever MVT module is being ran, and then finally you have the following log. And in some cases you have the path location. So if we scroll down, here are various MVT modules that are being ran, and then here is the resulting log from those modules. So it extracted 3,136 package activities, identified a total of 157 packages in Apps Ops Manager, and we do get some warnings. There is some suspicious activity around something called com.android.shell. And we continue to see additional modules that are ran by MVT. So we have 230 battery history records that were extracted, 2,131 database connection pool records, 1,752 Android system properties, and we get back a warning pertaining to a package that it has discovered that is installed on the phone. That package is the Magisk package that allows you to do a systemless root of the phone. I did install that package, so there's no cause for alarm there. But yeah, this is the basic structure of how this works. It's running modules. You're getting back the log for each. You're getting back the log from the modules being ran, letting you know step by step what is taking place. There were some errors related to the Tombstones module. The final analysis of the Android bug report, it did produce 3 detections. All right, so we're going to want to take a closer look at each one of those detections. Is this phone backdoored? Is there spyware on this phone? Is there malware on this phone? Or is it a false positive? Or is it something that maybe you did install and you forgot about? All right, so we're going to go ahead and clear the screen. And if we run the ls command, you can see that we now have a lot of files that we did not have before. Every one of these files ends in .json for the most part. Some of them end in .csv. Okay, so some of your files of interest that you are definitely going to want to take a closer look at are going to be anything that has detected in it. So you see that you have app_pops_detected, you have packages detected, and you have timeline detected. Anything with the word detected in it is going to be of importance, because that is going to have information inside of it potentially that has to do with anything that the tool set was able to detect. So for example, if we cat out the contents of packages_detected.json, we have information pertaining to a package that it was a package on this system that was detected as potentially malicious, and it is, depending on how it is used, but I did in fact install this. Nonetheless, this is where you would want to look. And some of the information that you're going to get is going to be, for example, when this particular package was installed and if it was updated, when it was updated. Were there silent background updates? And you also are shown the permissions that depending on how they are used are permissions that could be used maliciously. So I wanted to really put MVT to the test. I wanted to know if it would be able to detect, say for example, a Metasploit reverse TCP shell. So that is what I did. I actually took a common Android application and I backdoored it. I put a Metasploit reverse TCP shell inside of it, and then I recompiled the application. I signed it, everything, to the point where when I put it back on the phone, it was not detected by anything on the phone. It was not picked up by the Play Store. For all intents and purposes, this was a legit Android application. And I reinstalled the application back onto the phone. And I did a bug report. I pulled the bug report from the phone, and I'm going to show you what it looks like. I tried to hide it, but nonetheless, it was able to find an app that I had backdoored with a Metasploit shell. Specifically, you can see the line right here. It found a known suspicious app with the ID of com.metasploit.stage, matching indicators from Metasploit. So typically, an attacker would install a stager APK, and that stager would communicate back with a Metasploit handler on a remote host. Once the stager runs, it can execute commands, steal data, record audio, etc. And the stager is small. It's meant to intentionally be a smaller amount of code to try to fly under the radar, and then it communicates back with its handler, and then it's able to go further. And it found it. So I have a huge amount of trust in this tool that it can do exactly what it says that it can do, and it can do much more. This tool is just absolutely hands down one of the best tools, and something that has very quickly become a part of my daily workflow. I am checking every single phone with this tool set from now on. And that wraps up the process of creating an Android bug report, pulling it onto your Linux system, and running it through the very powerful Mobile Verification Toolkit to look for potential indicators of compromise. As you just saw, bug reports can reveal far more than most people think. And the Mobile Verification Toolkit helps us to turn all of that raw data into actionable, easy to interpret results. If you found this video helpful, like the video, hit that subscribe button, and let us know in the comments if you want to take things even further with what you can do with bug reports. Thank you for watching, and as always, keep learning and stay fresh. We'll see you in the next video.
In love with Linux, I got places to go. In love with Linux, I got places to go. In love with Linux, I got places to go. Yeah, because I know my way around the code. And my past was dark, don't mean I'm cold. I've made mistakes, yeah, I've seen the fall. But I'm in love with Linux and I'm standing tall. Bad past behind me, future in my hands. Terminal open, I'm making new plans. I'm not a criminal, I'm just running my own path. In love with Linux, leaving behind all the rest. Just because I have a